Hello and welcome to Forrester High School Maths Department's National 5 Maths Support Materials. My name is Mr. McDonald and I'll be talking you through your topic today. Today's learning intentions are to be able to find lengths of 3D shapes using Pythagoras Theorem. So here we have a 3D Pythagoras problem. We've been asked to find length through the middle of the 3D object from the bottom left-hand corner to the top right-hand corner, and that's denoted by the red dotted line going in that direction. We know that the length of the cuboid is 10 centimeters, the breadth of the cuboid is 4 centimeters, and the height of the cuboid is 7 centimeters. But that won't help us get that side unless we break it down into two separate questions. So the first question that we're going to try and answer is, what is the distance from the bottom left-hand corner to the back right-hand corner on the base of this cuboid? I've drawn a blue line in to denote that. Okay, we'll be using this blue triangle here. Okay, so let's answer that question first. In order to get that side there, x, we are going to use Pythagoras theorem for the longest side of the triangle. So c squared equals a squared plus b squared. X squared, which is our missing side, is equal to 10 squared plus on 4 squared. X squared is equal to 100 add on 16. X squared equals 116, adding those two things up. And that means x is equal to the square root of that, which is 10.77 centimeters. Okay, so that's the first part of this problem. We found the distance from the bottom left-hand corner to the back right-hand corner along the base of our 3D object. Now we're going to use that along with the height of the 3D object to find what I'm going to call y, which is our length going from the bottom left-hand corner to the top right-hand corner. So again, we're going to do Pythagoras theorem, c squared equals a squared plus b squared. Y squared this time is 10.77 squared, that's our diagonal length across the base, plus on 7 squared. And that's our height of our cuboid. Squaring those numbers, y squared is equal to 115.99 plus on 7 times 7 is 49. Add those two up, y squared is equal to 164.99. And y is going to be the square root of that. Which is equal to 12.84 centimeters. Okay, so that is a 3D Pythagoras question. Usually what you're looking for is you're looking for a side on the base or on the side of your 3D object, and then you're going to use that value in another round of Pythagoras to find a side length that's diagonal through space. Okay, so here's another variation of a 3D Pythagoras problem. Here we're given a square base pyramid. We know that the square lengths of the base are 8 centimeters each, and we know that the height of the pyramid is 6 centimeters from top to bottom. We need to find what the length of one of the diagonal sides going from the base to the point is. Okay, so we're looking for this diagonal edge running from the bottom to the top of the pyramid. First step here is trying to figure out one of these diagonal lengths that I've noted on the bottom of the pyramid. So I'm going to draw a few lines in to show you just which side length I'm looking at. So this blue triangle here is what I'm going to be working from. I already know two of the side lengths of the blue triangle. I know that this half of my squared base is going to be 4 centimeters. I know that this half going backwards of my square base is going to be 4 centimeters. I don't know the diagonal length into the middle though, and that's my x. So again, c squared, oops, that's rubbish. Let's try that again. C squared equals a squared plus b squared. X squared is equal to 4 squared plus 4 squared. X squared is equal to 16 plus 16. Add them up. You get that x squared is equal to 32. And x is equal to the square root of 32, which is 5.66 centimeters. Okay, so now I have my diagonal distance x into the center of the base of my square base pyramid. What I need to do now is use that and the height, the 6 centimeters that is off to the side there, to find my diagonal length on the outside of my pyramid. So I'm going to change to red because we're now looking for this red line on the outside. I'll draw a red line, that's probably best. So I'm looking for this red outline here, and I'm going to call that y. Okay, so that's my length y. So c squared equals a squared plus b squared. Y squared is equal to 5.66 squared. That's my diagonal length on the base, plus on 6 squared, which is my height. Y squared is equal to 32.04 plus on 36. I'm going to move over the page, so add it up, y squared is equal to 68.04, and my final answer, y, is going to be the square root of 68.04, which is equal to 8.25 centimeters. Oops. Okay, so that's 3D Pythagoras. Normally you use one length that you find either into the base or into the side of the 3D object, and then use that in tandem with another side that you haven't used yet to find your 3D length. Well done for reaching it this far into the video. Remember, when you're doing your assignment, you can ask questions. You can do it. Remember to be resilient. I'm always here to help. And you've been killing it so far, so well done. And remember, once you've finished your solutions, upload onto Teams. Excellent work, Nat 5s, and I look forward to seeing your assignments.